Good morning. Today we are continuing our discussion about vectors. And so today's focus is going to be x and y components. Yesterday was magnitude and direction, and today is x and y components and how we find them. So, how would you solve for x and y given this, using this given information? We have the hypotenuse and we have the angle measure. And so if we drop this, we can think through this as like, this is my y value. And then if we draw this part, this is my x value. It's not drawn to scale, but it is a right triangle, and you know how to solve some things using right triangles. And so if this were just a free-floating triangle, what I want you to think about with your partner is, how would you solve for y? What math, which trig function might you use to solve for y? And then which trig function might you use to solve for x? So pause the video and chat with your neighbor and see if you guys can come up with an idea of how to solve a missing side on a right triangle. Okay, and so hopefully what you're seeing here is that you have the hypotenuse, you have the angle measure, and you have the opposite side. And so we've talked about this back when we first started trig. The y value and the opposite side were the same always if we drew our triangle in this orientation. And so we could use sine to solve for our opposite side. If we have the opposite side and the hypotenuse, or we want the opposite side and we have the hypotenuse and we have the angle measure, sine of 55, or the angle measure always goes on the inside, equals opposite over hypotenuse. So the y value over 25. And then if we're solving for the x value, we could use, we could use cosine of 55. Remember, the angle measure always goes on the inside. The angle measure is the degrees, and that equals the adjacent side over the hypotenuse, which is 25. And so hopefully you see that these two situations, are almost identical. We're just using different trig functions. We have 55, we have the hypotenuse, and so in both of these situations, to move or to get x by itself, we can move the 25 to the other side. We can move the 25 to the other side on this one. And so every single time we're given the magnitude and the direction, the formula for this is going to be the magnitude times cosine of the direction and the magnitude times sine of the direction, just like we saw in the math before. So take a second and copy this down. Remember that this means magnitude and this means direction, or the. Okay, and so we saw this yesterday, that there's a magnitude and a direction. We have component form, and so this would be component form when we have the triangle brackets on the outside with x and y being on the inside, x comma y, just like always. And then you could also write this in the linear combination form, which is xi, the x value, I, and the y value, j. And so this is just a summary of everything we've talked about so far. All of this was day 1, all of this is day 2. So if we're going from x and y to magnitude and direction, we're using Pythagorean theorem and inverse tangent with some additions. And then if we are going from magnitude and direction to x and y, we're using sine and cosine times the magnitude. Okay, let's see how this plays out. So our magnitude is 550, and our direction is 320. And so that means that we're going to be in quadrant 4. So 270 is here, 360 is here, so we're going to be somewhere in between. I know that this is 550, and I know that my direction is putting me in quadrant 4. And so my triangle is going to be in quadrant 4. And so I have 550 times sine of 320, and I have 550 times cosine of 320. Make sure that your calculator is in degrees, and you can do this math with me to make sure that you're doing this right. And so we end up with negative 353.5. That's my y value. And my x value is 421.3, which makes sense because my x is going in the positive direction, 421.3, and my y value is going in the negative direction, negative 353.5. So on this one, we have our magnitude is 45 miles, and our angle measure is 125 degrees, and so that's going to live in quadrant 2. So I draw my arrow and triangle in quadrant 2. The angle measure that gets me over here is 125, and the magnitude is 45 miles. And so as I work through this, my x value is 45 times cosine of the angle measure, and my y value is 45 times sine of the angle measure. And so go ahead and put that in your calculator and double check and make sure that you're on the right track with me. This should be negative 25.8, and this one should be 36.9. And so we can label those in our triangle. And so this one would be negative 25.8, which makes sense because I'm going left and then I'm going up, and so that one should also be positive. And so the nice thing about this is that your information should all line up with whatever's happening in your picture. Negative, positive, angle measure in quadrant 2, like all of that should be lined up together. And so I forgot to do this on the other problem, but making sure that you can also put it back into vector form. So we can call this vector V. Sometimes they put a little arrow on top, notating that it's a vector. So there's several different ways you could see the notation of this happening. And so if we go back to this one, our vector on this one would be 421.3 and negative 353.5, because this is our x value and this is our y value. So x is first and y is second.